So this acceleration, in that acceleration, if the object changes their speed or changes their direction, or in many cases if changes both, then in that cases the velocity changes. So if speed changes or the direction, if any object changes their speed or changes the direction, or if both, then the velocity also changes. Then in that cases the velocity also changes. So just consider a small example. If you are drive the car and at the curve road, so in that curve road you can take a turn. So in that case your velocity, initial velocity is v1 and after final velocity is v2. Your speed is constant. In that case your speed is constant, but you change your direction. So in that case you change your direction, which is you are taking the turn. So in that case your velocity will be changes. Initially it will be v1 and final velocity at the curve place, which is v2. Or another example, you can say that same you can going on the road by car. If suddenly there is any obstacle, so driver suddenly apply the brake. So in that case you are not changing your direction. In that example you are not changing your direction, you are changing your speed. So in that case also we say that here we can see that the velocity will be changes. So your acceleration, we can say that the change in velocity if your speed changes, or it may be your direction will be changes, or in some cases if your speed as well as direction changes. So here you can change the velocity of that particle. You change the velocity of that particle by changing the speed or by changing the direction. So the velocity is a function of time. Here the velocity, which is the function of time. So we can say that the rate of change of velocity, the rate of change of velocity over a time interval. Over a time interval, it gives us the acceleration. It gives us the acceleration. So this acceleration is the rate of change of your velocity. This velocity is a vector function. You know that if it is a vector function, it's having magnitude as well as direction. So your acceleration is also a vector quantity. It's having a magnitude as well as the direction of that. So here rate of change of velocity having your vector quantity. In our acceleration, now we look for the average acceleration and the instantaneous acceleration. So in the average acceleration, we can define as any particle changing their positions. This average acceleration is nothing but the change in the velocity. Change in velocity, we can say that delta p with the time interval delta t. So this is nothing but the ratio of delta p divided by delta t. We can consider it if any object changes their position, in that at initial time t1 the velocity is nothing but v1, and at the time interval t2 if the object changing their position with velocity v2. So the difference between the velocities delta, this delta is nothing but v2 minus v1, and the difference between the time interval, which is delta t, which is equal to average acceleration. Your average acceleration we can say that it is the ratio of your delta P divided by delta T, or you can write V2 minus V1. It is V2 minus V1 divided by your T2 minus T1, or you can write delta P divided by delta T. So this ratio of your change in the velocity over a time interval delta T gives us the average velocity. As with this velocity, if when this motion is analyzed along the your any one dimensional component, one dimensional entity, so this sign of your this positive or negative this positive average acceleration sign, which is positive negative, which indicate the direction of your object or of your motion. So we can from these values we get the direction. Now you know that your velocity is nothing but the dimension of your velocity is, or unit is meter per second. This is basically unit, and the dimension are length per time, so which is L by T. And in case of your acceleration, it is the dimension is L by T square. So length per meter per length per time per time. So your dimension for your acceleration is nothing but L by T square. So if you want to determine the velocity of the interval or time interval, or you can say that at the instant of that time, so you need to study the instantaneous acceleration. Same here also we have to study just like similar to your instantaneous velocity. You can, by using this instantaneous acceleration, you can check or determine the change in the velocity for small time interval. So you know that your average velocity, in case of your average velocity, it is the ratio of your delta x by delta t, and here in your instantaneous acceleration, your instantaneous acceleration is delta p divided by delta t. Again in that case we can pen, here also we is considering the limit your delta t, your time interval which is approaches or close to 0, your velocity will be close to 0. Similarly, in last point, in your instantaneous velocity, we study the same concept. So you delta t, you are considering here limit, and in that limit your delta t which is approaches or tends to 0. If your delta t tends to 0, which is close to the 0, your delta p also approaches or tends to 0. And here we are considering the limit, your acceleration, which is nothing but limit delta t tends to 0 into your delta p divided by delta t. Your delta p divided by your delta t, or you can write it is the derivative of, from this limit delta t tends to 0, delta p by delta p, we can write the derivative of dp by dt. And you can say that it is the rate of change of your velocity with respect to time. This derivative gives us the rate of change of your velocity with your time instant. So by using this derivative dv by dt, you can determine how any object changing their velocity with small time interval or at that instant of time. So you making the your delta t closest to 0 tends to 0. As delta t tends to 0, which is close to the 0, your delta v also tends to 0. And considering this limit, you get this value dv by dt, which is gives us the instantaneous acceleration. So from this formula, we are defining your instantaneous acceleration. Your instantaneous acceleration is the limit of your, it is a limit of your average velocity as your time, this time is approaches to 0, is the rate at which, it is the rate at which your velocity over a time interval, over, this is the rate of change of your velocity over a time interval with time given at that instant. So you get this, the derivative of your velocity with respect to your time, or you can defining, you know that your velocity is nothing but your velocity p is nothing but dx by dt. It is the rate of change of your displacement over a time. So you can defining again your acceleration. Your a is equal to, it is rate of change of your velocity over a time, which is nothing but d by dt into dx by dt, and finally you get d2x by dt square. So you get your acceleration equal to double derivative of your position or displacement over a time interval, d2x by dt square. So here you considering your acceleration in a one dimensional, it is the second derivative. It is a second derivative of the displacement, the object which is displaced from one position to another position. So your acceleration in one dimensional case, we are considering one dimensional case, in that acceleration is nothing but the second derivative of your displacement over a time interval. Again we are considering if this movement or this displacement which is along the x direction, then your acceleration, I am writing ax because I am defining their direction, which is ax is equal to dtx by dt, or into, or you can say that dtx by dt into I cap, and this unit vector I cap represent the direction of that motion or the velocity which is along the x direction, which is along the x direction. Object changing their position from one place to another place with along your x direction. So this I cap is representing the direction, because your acceleration is also a vector quantity. So here you need magnitude as well as